My name is Vatsal Shah. I am a student of semester 4, Infrastructure Engineering and Management PDEU. The topic of this study is Geospatial Multi-Criteria Decision-Making Approach for Alternative Landfill Site Selection in Vadodara, Gujarat. In this study, I have been guided by Dr Naimish Bhatt and Dr Shobhit Chaturvedi. QGIS is a free, open-source, cross-platform desktop GIS application that supports viewing, editing, printing, and analysis of geospatial data. QGIS functions as a GIS software that allows the user to analyze and edit spatial information. It also supports composing and exporting graphical maps. QGIS supports mesh layers such as raster vector. Vector data is either stored in point, line, or polygon features, and multiple raster images are supported that can be geo-referenced further. As you all can see, this is a QGIS software in which we can open any vector layers or raster layers and we can as well create it. For example, this is a vector layers which consists of points and polygon, and these are the example of raster layers which contains data. The objectives in these studies are first, to identify factors or criteria for landfill site selection. Second is to develop thematic layers as per the selected criteria. Third is to apply analytical hierarchy process, that is an MCDM method, to a certain criteria weightage. Fourth is to apply the GIS-based topses approach to select optimum landfill sites by using relative ranking. In this study, a framework is prepared in which first the criteria are identified, then a data collection is done on the basis of primary data and secondary data. In primary data, satellite images, DEMs, graph survey, raster data, topo sheet are prepared, and in secondary data, topo sheets, VMC data, field data are generated. All this data are then processed and rasterized buffer map is created. After the data collection is done, thematic layers are prepared on the basis of criteria. The layers are then assigned classes based on the suitability scores, and they are classified in the scores of 5 to 1. To determine the weight of the criteria, a MCDM technique AHP, that is Analytical Hierarchy Process, is used. In AHP, pairwise comparison are prepared, which shows the comparison between individual criteria. After determining the weights from the AHP, a suitability map is then prepared using raster calculation in QGIS software. After obtaining suitability map, 8 highly suitable sites are then selected for relative ranking. After relative ranking through topses is done, we get to know the most suitable alternative landfill site. For this study, Vadodara City is taken into consideration. Vadodara is a city which is located in Gujarat and is said to be second most populated city in Gujarat. Vadodara covers an area of about 420.33 km square, which is second largest in Gujarat. The city generates about 750 tons of municipal solid waste per day. Criteria identification is done with the help of expert survey, and also the literature from similar study was taken into consideration. The criteria obtained are elevation, slope, land use, land cover, build-up, water bodies, vegetation, railway, road, airport, lineament, land surface temperature, land value, groundwater, and transfer station. The table shows the data type, data resolution, and data sources. The criteria are then divided into 5 classes and are assigned the scores between 1 and 5, in which 5 indicates highly suitable, 4 indicates moderately suitable, 3 indicates suitable, 2 indicates less suitable, and 1 indicates unsuitable. For this study, individual subclass thematic raster map were prepared for individual criteria. As shown before, individual criteria maps were prepared. Individual criteria maps according to their classes are made. This map shows 5 classes which are less than 250, 250 to 500, then 500 to 750, 750 to 1000, and more than 1000. For every criteria, red is unsuitable and blue color is highly suitable. After the thematic maps according to their criteria are prepared, the criteria maps are then reclassified in the scores of 1 to 5. In this map, 5 shows the maximum suitability and 1 shows least suitability. For determining the weightage of the criteria and also to compare the criteria, a MCDM technique named as AHP, that is Analytical Hierarchy Process, is used. In AHP, pairwise comparison between different criteria is done. After pairwise comparisons, the weights are then normalized to obtain the final weightage. A consistency check is also required. In this study, the consistency ratio is 0.042, which is less than 0.1, so the weights obtained are okay. With the help of AHP, the final weights were taken into consideration. The final weights are as shown in the table, in which LULC is given the highest weightage and railway is given the lowest weightage. With the help of weight obtained by AHP, a final suitability map was prepared with the help of raster calculation in GIS software. A final suitability map is then prepared with the help of raster calculation in QGIS software. The equation includes the multiplication of reclassified raster files with their respective criteria weightage. After the raster calculation is done, a final suitability map that is shown in the screen is obtained. The final suitability maps includes 5 that is highly suitable area and 1 that is unsuitable area. The blue color indicates highly suitable area and the red indicates unsuitable area. After the suitability map is created, 8 different sites were marked in highly suitable areas for relative ranking. 0.8 of individual sites were taken into consideration for Tops's method of relative ranking. With the help of Tops's, we come to know about the highly suitable site, which is site number 2, followed by site number 8, 6 and 5.